5 May, June, paper 11. Let's take a look at question number 1. Prove by mathematical induction that this expression is divisible by 15 for all positive integers. So what you need to do, usually I will just let the expressions over here call Fn 2 to the power of 4n plus the 31 power n minus 2. So when the n is equal to 1, I have f1 is equals to the 2 to the power 4 plus 31 power 1 minus 2. That will be 45. So 45 is divisible by 15. So it's true for n equal to 1. Now we assume it's true for n equal to k, which means that the fk 2 to the power of 4k plus the 31 power k minus 2 is divisible by 15. We assume the second statement is true. Now we want to go for n equal to k plus 1. So we want to show that when n equal to k plus 1, it is still true. So what you can do is that, first of all, we find fk plus 1. Fk plus 1 is 2 to the power of 4k plus 1 plus the 31 power k plus 1 minus a 2. Okay, so you can write it as a 16 multiplied by the 2 power 4k plus the 31 multiplied by 31 power k minus 2. So we just take the fk plus 1 minus the fk. Then you will get 16 to the power of 4, 2 to the power of 4k. Okay, so this is the fk plus 1 minus fk. Minus fk will be 2 to the power of 4k plus the 31 power k minus 2. So you will get this one as a 15 6 power 4k plus the 31 power k. So they actually, you can see that we write fk is equals to the 15 multiply 6 power 4k plus the 2 times 31 power k plus the fk. Since we already know that fk is divisible by 15, this is divisible by 15, this is the multiple of 15. Okay, so therefore, because of fk is divisible by 15, therefore fk plus 1 is divisible by 15. True for n equal to k plus 1. So this is the answer. This is how you prove that fk plus 1 is divisible by 15. Now we move on to the conclusion. The conclusion is by the BMI, the 2 to the power 4n plus the 31 power n minus 2 is divisible by 15 for all positive integers. Done. This will be the answer for question number 1. Now we move on. We have question number 2. simplifying your answer. So what you need to do is just to refer to your formula booklet MF19. So the sum of 1 is n. Then this one r is n plus 1 over 2. Then this one it will be n plus 1, 2n plus 1 over 6. So they all have a common factor 1 over 6n. You can take 1 over 6n out. Then you have a 6 minus the 3n minus 3 minus the 2n squared plus 3n plus 1. But if you expand and simplify, then you will get 2 minus the 6n minus the 2n squared. Factorize the 2 out. Cancel with the 6, simplify with the 6, then you get 1 minus 3n minus the n squared. So then this will be the answer for the number 2a. Now we're going for b. Show that these fractions can be decomposed into the partial fraction like this. Then after that, use the method differences to find the sum of these terms. So what you need to do is either you go from left to right or you go from right to left. So over here, actually, it's easier if you go from right to left. So it will be right-hand side like this. Then you cross multiply the opposite denominator. Here, I will expand them so that I will get r squared plus 2r plus 2. The two denominator over here combine together, multiply together. Then your numerator, you expand, you get the r cubed plus the r squared plus r plus 1 minus the r cubed minus the 2r squared minus the 2r. Divided. We don't need to expand the denominator. Just leave it in a factorized form. Then you can cancel this. You will get 1 minus r squared divided by r squared plus 2r plus 2 multiplied by r squared plus 1. Shown. That is how you show the answer in the first part. Then after that, we want to use the method differences to find the sum. So we just take these expressions, change it to the left-hand side form, then you will get this. R plus 1 over the r plus 1 squared plus 1 minus the r over the r squared plus 1. List down the terms. You can just write, put the value 1. You get 2 over 5 minus half. Put the value 2, you will get 3 over 10 minus a 2 over 5. R equal to 3, you get a 4 over the 17 minus the 3 over 10. And you can see that the pattern for the cancellations will be like this. So this pattern will remain the same until the R become n. However, we will write one more terms before n. That means where the n is, where the r is equal to n minus 1. And you can see that this can be cancelled. And the rest can be cancelled in such a way. So at the end, this will be equals to the n plus 1 over the n plus 1 square plus 1 minus half. So this will be the answer. Or if you want, you can also expand the denominator but that is not necessary. So this will be the answer for the number 2B. Now we move on. We want to find the sum to infinity. So to find the sum to infinity, we just need to let the limit of n approach to infinity. So it will be the limit of n approach to infinity with the expression that we have found earlier in the part B. So you can see that when the n go to infinity, this will be a 0 minus half. It's a negative half. So we just write negative half, we'll do direct write negative half. Done. This will be the answer for number 2C. Move on, we have a question number 3. We have a quadratic equations over here, look like this: x power 4 minus 2x cubed minus 1 equal to 0, and has the alpha, beta, gamma, delta are the roots. So we want to find a new quadratic equation that formed by alpha cube, beta cube, gamma cube, and delta cube. After that, we want to state the value of the sum of the cube of the root. Okay, so over here, we will let the y be equal to the x cube. That means the x will be equal to the y to the power of 1 over 3. So x power 4 minus a 2x cubed minus 1 equal to 0. That will be y power 4 over 3 minus a 2y minus a 1 equal to 0. So you get y to the power of 4 over 3 is equal to the 2y plus 1. And you cube both sides. And you get this. Expand. You get y to the power 4 is equal to the 8y cubed plus the 12y squared plus the 6y plus a 1. Then you get y to the power 4 minus the 8y cubed minus a 12y squared minus a 6y minus 1 equal to 0. So therefore your alpha cube plus beta cube plus gamma cube plus delta cube is equal to the positive 8. Done. That will be the answer for the number 3 part A. Now we move on to the 3 part B. We want to find the reciprocal of the root, the sum of the reciprocal of the root of 1 over alpha cube plus 1 over beta cube plus 1 over gamma cube plus 1 over delta cube. So over here, what I usually do is I will take these equations and I divide by the highest power of y. So that means I just copy down these equations from the part A. I divide everyone by the y power 4. I get 1 minus the 8 over y minus the 12 over y squared minus the 6 over y cubed minus a 1 over y power 4. So I will get this. Then therefore 1 over alpha cube plus the 1 over beta cube plus 1 over gamma cube plus 1 over delta cube, it will be equal to negative 6. Done. This will be the answer for the question number 3B. Now move on, we have a 3C. 3C, they want you to find the alpha power 4 plus beta power 4 plus gamma power 4 plus delta power 4. So from here, the original equations, I make it become x power 4 equal to the 2x cubed plus 1, which means that I let the Sn equal to alpha power n plus beta power n plus gamma power n plus delta power n. I will get S4 equal to the 2S3 plus the S0. I already have S3. Okay, S0 is nothing difficult. S0 is a 4. So over here, we will have a 2, 8 plus a 4. And you get a 20. Done. This will be the answer for number 3C. Moving on, we have a question number 4. Rotations of anticlockwise, 60-degree anticlockwise about the origin, followed by a one-way stretch in the x directions, scale factor d and d not equal to 0. You want to find m in terms of d. So what you need to do is to let matrix A represent the rotation 60-degree anticlockwise. There will be cos 60, sine 60, negative sine 60, and cos 60. So you will get half square root 3 over 2, negative square root 3 over 2, and then half. That will be the matrix A. And the matrix B is represent the one-way stretch in the x directions. That will be D0, 0, 1. So your M is actually BA. Then just multiply them. It's a very straightforward product of two matrices. So you will get this one as the D over 2, negative 3D over 2, and 3 over 2, and a half. So this will be the answer for the question number 4A. Move on. We have a question number 4B. We have a unit square. This is meanings of the area is 1 unit, and this is the object. Transformed by M, and it become a parallelogram of area of half d square. Show that the d is equal to 2. So we need to find the determinant M. Determinant M based on the M just now is based on this M. It will be d over 4 plus 3d over 4. Then you will get a d. So the area of image is equal to the modulus of a determinant M multiplied by the area of object. So area of image is given as a half d square. This is the modulus d. This is the 1 because they say 1 ut square means the area is 1. So over here we will multiply it. Okay, because the d is not equal to no, the d, they didn't mention the d is positive. They only mentioned that the d is not equal to 0. Okay, but however, in order to get half d square, the area is positive. So that means the d over here we will take positive. So we will get the d square minus the 2d equal to 0, and then you get this. The d is equal to 0 and the d is equal to 2. This one need to be rejected because the question mentioned that the d is not equal to 0. So therefore your d is a 2, shown. Now we move on to the C. We need to find the, given that the product of M and N will give you this result, we need to find the N. So to find the N, actually, we know that we have to put the, multiply the M inverse. Then we can only get N. So that means before we find the n, we need to find the m inverse. And to find the m inverse, we need to replace the d equal to 2 inside the m. So your m, change the d become 2. This is the m. Change your d become 2. Then you will get 1 negative Z3. And then Z3 over 2 and half. Then we find the m inverse. M inverse will be the 1 over half plus the 3 over 2. These two swap. This one change the sign. And you will get this as the 1 over 4. So 3 over 4. This is a Z3 over. Oh, I make a mistake. This is no Z2. Okay. This one is a positive Z3. This one is the half. Okay. So this one, it will be this and this. That will be your m inverse. Then we just write mn is equal to the 1, 1, half, half. Then the m inverse, need to show the how to calculate, need to show the procedure, the steps for finding the n. So it will be like this. Then just multiply as usual, a very normal multiplications over here. So you will get 1 over 4 plus 3 over 4. This will be 1 over 4 plus the 3 over 4. This will be negative 3 over 4 plus 1 over 4 and negative 3 over 4 plus the 1 over 4. We can factorize the 1 over 4 out so that the inside here we can write them in such a form so that it will looks better. So this will be the answer for the question number 4C. Move on. We are going for the D. We want to find the invariant lines through the origin and transform in the xy plane represented by the mn. So what you need to do is we let the invariant line is y equal to mx. Then it will become y prime equal to the mx prime. So mn is 1, 1, half, half. Multiply the object. Then you will get the image. So just expand them. You get the x plus the half mx. Half x plus the half. This one is m, no half. And you get x prime mx prime. So by comparison, you get 1 plus m x is equal to the x prime. That will be your equation 1. And then half plus half m x is equal to the mx prime. That will be your equation 2. Then take the first equation divided by the second equations. You get a 1 plus m divided by half plus half m is equal to 1 over m. You get m plus m square is equal to the half plus half m. Multiply everyone by 2. 2m plus the 2m square is equal to the 1 plus m. you get a 2m squared plus m minus 1 equal to 0. Factorize it. 2m minus 1. And the m plus. Okay. So therefore, your m is a half and your m is a negative 1. Okay. So therefore, your invariant line is y equal to the half x and y equal to the negative x. Done. That will be the answer for question number 4D. Move on, we have a question number 5. Has a polar equation like this, where the A is a positive constant and the theta is measured from 0 to pi over 6. Given that the greater distance of a point C from the pole is 2 over 3. This one typing error. Ignore this. Show that the A is equal to 2. Okay, so what you need to do here is in order to sketch a graph, we usually will need to have a table. This is the theta, this is the R. You start from 0 and you will stop at pi over 6. So maybe over here in between, I get pi over 12. I have a pi over 12 here. So just use a calculator, put a 0 inside. You'll get a cotangent half 1 over 3 pi. A cotangent 1 over 3 pi, if you convert to decimal, is actually a 3 over 3a. Then this one, if you put it inside, you will get a. This one, if you put it inside, you will get a 3a. So you can see that this is the largest. If the a is positive, then this will be the largest. Okay, so and then they say that the greater distance is this. Okay. So we know that the a is a 2. Okay, so from here, given the R max is equal to the 2 sub 2, 2 sub 3. So the sub 3a is equal to the 2 sub 3. Then the a is equal to 2. Shown. Now we want to plot the point. To plot the point, we actually need to convert them into the decimal place. This is 0.68. Oh, sorry. We have found the a. A is a 2. So if you use if you change the a become 2, so this one will be 1.2 approximately. This one will be a 2. This one will be a 2 sub 3, around 7.4. Okay, around 7.4. So from here we can actually draw the diagram. I draw in freehand, but in exam you cannot draw in freehand. In exam you need to draw with the proper scale and with the proper tools. Use a ruler. So this one is a pi over 12. Theta is a pi over 12. And this one is the theta is equal to the pi over 6. So just plot the point. A is a 2. Then this one is this one is 1.2. Then 2. Then 3.4. So your answer, your graph will be like this. Okay, so this will be the answer for the question number 5A. Then number 5B, we want to find the exact value of the area bounded by the C initial line and the half line of theta equal to pi over 6. Means we are looking for this area. So we need to integrate. Zero to pi over 6 r squared d theta. So your r is actually a cotangent pi over 3 minus theta, and the whole thing you square it. But we know the a is a 2 already. So we direct square it to save our time. We direct square it, it will be 4 cotangent square. So it will be a 2. Then cotangent square, we cannot integrate cotangent square directly. By applying the trigonometric identity, we know that the cotangent square is a cosecant square. Minus 1. So integrate cosecant square, you can just check the formula booklet. Cotangent square will give you cosecant square, integrate, you will get cotangent. You should get a negative, but because there's a negative here again, so the negative will become positive. So this will become positive. And minus a theta from 0 to pi over 6. Substitute the value inside, you will get cotangent pi over 6 minus a pi over 6 minus a cotangent of pi over 3. We want exact value, so have to be careful. Cotangent pi over 6 is sub 3. Tangent pi over 3 is sub 3 over 3. So at the end, you get this as a 4 sub 3 over 3 minus a pi over 3 unit square. Done for the 5B. Now we move on to the 5C. Show that the Cartesian equations of the polar curve can be represented in such a way. So over here, we actually know that the r is the square root of x squared plus y squared. We also know that the tangent theta is equal to the y over x. Okay, so our equations over here is given. So they give you cotangent. I need to make it become tangent. So I'll put it aside. Use the compound angle formula. Tangent pi over 3 minus a tangent theta divided by 1 plus the tangent pi over 3 tangent theta. So you should know that tangent pi over 3 is a sub 3. So we can get something like this. This is a y over x. This is the square root of x squared plus y squared. This one is the sub 3 minus the y over x. So I multiply everyone by x first. The numerator and the denominator by x. Then I get 2x, 1 plus x plus 3, y. And this one, it will be x sub 3 minus a y. Then when I multiply them to the other side, so therefore, you will get 2x, x plus sub 3y is equals to the sub 3, x sub 3 minus a y square root of the x squared plus y squared shown. This will be the answer for the question number 5C. And moving on, we have a question number 6. We have the t is a positive constant. The line L1 passes through the position vector as given and parallel to this vector. And we have a line L2 passes through this position vector and parallel to this vector. It is given that the L1, L2, the shorter distance between the line L1 and L2 is a square root 2. Find the value of t. So what you need to do is to form the equations of the line L1 first in the matrix form. So I will use position vector is a t10 lambda. Then the L2 is 0, 1t. This one I use a parameter mu. You have a negative, you have a 0, negative 2, and 1. So I let this OA is the position vector, t10, and let OB is equal to the 0, 1t. Then we find AB. AB will be the B minus A. It will be negative t, 0, and then t. Then we need to do the cross product between the line L1 and L2. Cross product. I, J, K. Negative 2, negative 1, 0, 0, negative 2, 1. So you will get this one as the negative I plus the 2J plus the 4K. Okay, so now the D, the formula, is actually given as the modulus the AB dot with the normal vector divided by the magnitude of a normal vector. But they give you the D is a square root 21. So we just direct use a formula. And you can see that this is also square root 21. So square root 21 multiplies square root 21, you get 21. So you can modulus of a t plus the 4t. So you get the 5t is equal to 21. Then the t is equal to 21 over 5. Because of the t is positive, you ignore the negative value. So that will be the answer for number 6a. Move on, we have a 6b. We have a plane pi 1 contain L1 and parallel to L2. So we want to find the pi 1 equations in the form of vector equations of pi 1. Okay, vector equation of pi 1. Okay, so what you need to do is we the directional vector for this one is a negative. Directional vector is a negative 2, negative 1, 0. And the directional vector for L2 is a 0, negative 2, 1. So this will be the vector B and C. So over here, we just write the answer directly. So it will be negative 2, negative 1, 0, and 0, negative 2, 1. Over here, we will use the A will be the position vector in L1. Position vector in L1 just now was T10, but the T is already found, 21 over 5. That is the answer for the number part B. This information is for the part C. So we will carry this information. It's a pi 2. I make a mistake in the typing error. Sorry for that. Okay, so it's pi 2. We have the Cartesian equation look like this. Then we want to use this information to go to the part C to find the acute angle between the line L2 and the pi 2. So my pi 2, let me just copy down the answer, is 5x minus 6y. Sorry, another typing error. Too many typing errors over here. 5x minus a 6y plus a 7z equal to 0. So my N2 is actually 5 minus 6 and then 7. So to find the acute angle between, so that means actually we are having a normal vector and we have a L2 over here. So we are looking for this angle alpha, but when we do the product, we'll find the angle theta. So we take the dot product between the L2, we'll get cos theta. So acute angle, so we put modulus. So this is the n. It will be 25 plus 36 plus the 49. Then the L2, just now L2 was 0, negative 2, 1. So it's 0 plus 4 plus 1. So if you use your calculator, you will get this as 12 plus 7 divided by square root of 110 and square root of 5. So your theta will be the 45.9 degrees. So your alpha plus theta is equal to 90. Oops, it's a 35, not 45. So your alpha is equals to the 90 minus theta. 90 minus theta will give you 54.1 degrees. Done. This will be the answer for the question number 6C. Now move on, we have a 60. We want to find the angle between the pi 1 and pi 2. So our N2 just now was N2 just now was 5, negative 6, 7. So now I need to find the N1. So N1 is actually here. This is the N1. Because just now the N1 is coming from the cross product between the two vector L1 and L2. So the pi 1, it's contain L1 and parallel to L2. So if you take the L1 and L2 cross product, you will get an N1. And we have found it in part A. So we just say that from the part A, the N1 is equal to the negative 124. Okay, so your dot product N1 dot N2 equal to the magnitude N1, magnitude N2, I call it beta, modulus negative 124. It will be 1 plus 4 plus 16, 5, negative 6, 7. Just now we know is a 110. So our cos beta is equal to the negative 5, negative 12 plus 28 modulus divided by square root of 21, square root of 110. Press a calculator and you get the beta is 76.8 degrees. Done. This will be the answer for the question of 6D. Now we move on. We have a 7C. We have a question number 7. Of the C, equations of the asymptote of C. So what we need to do is we start from the vertical asymptote. We let the denominator equal to 0. Then you can x equal to negative 1. Okay, then after that we want to find oblique asymptote. So we know it will have an oblique asymptote because this is an x squared, this is an x, so it will have oblique asymptote. And in order to do oblique asymptote, we need to use the long division, or you can try to factorize the terms of, try to rearrange that so that the expression in the numerator has the same expression as the denominator, so that you can split them out, become this. So therefore, your oblique asymptote will be y equal to x. So this will be the answer for number 7A. Now we move on to the B. We want to find the coordinate of the stationary. So from the part A just now, we already have these equations. So to find the dy dx, we differentiate from here. Then you get this. To find stationary point, your dy dx will be 0. So you get 1 equal to the 9 over the 1x plus 1 square. So you get x plus 1 square is equal to 9. Then you get x equal to negative 1 plus minus 3. So your x will be a negative 4 and x will be 2. When x is a negative 4, you need to press the calculator. You can get the answer, the y is a negative 7. Then when the x is a positive 2, your y is a 5. So therefore your stationary point will be negative 4, negative 7, and 2, 5. Done for the number 7B. Now we move on to the C. Now we need to sketch a graph and we need to state the coordinate of any intersections of the axis. So when the x is equal to 0, so your y, just substitute 0 inside here, and you get a 9. So your y is a 9. Then when the y is equal to 0, which means that your numerator is x squared plus x plus 9 is equal to 0. So over here, actually, you can check the b squared minus 4ac. The discriminant is 1 minus the 36. That will be negative 35, less than 0, no real value. However, we don't need to show that. We can just say that no real solutions. So therefore, we only have the y-intercept. We don't have x-intercept. So now we are ready to sketch a graph. Sketch with the proper scale. Over here, I draw it freehand, so I will not show the proper scale. This is your vertical asymptote. This is your oblique asymptote. This is a 9. This is a 5. This is a 2. So your graph will be something like this. That is your y, that is your 0, that is your x. And we have another stationary point, which is a negative 4 and negative 7. So if you extend the graph, then your graph will look something like this. Okay, so this will be the y equal to x. This will be the graph of y equal to the x squared plus x plus 9 divided by x plus 1. That will be the answer for the question 7C. Move on. We have a question 7D. They want you to sketch the graph of y equal to the modulus of the function just now. So what we need to do is actually just need to, the whole thing over here is going to reflect about the x-axis. So you just have to your oblique asymptote is y equal to x. Then it will reflect. So this is a 5. This is a 7. and this is a 9. This is a 2. This is a -4, and -4 somewhere here, 7. So you can sketch a graph. Your graph will be something like this. And sketch a graph look like this. Oops. Okay. Then this will be like this. Okay. So this will be the graph of y equal to the modulus of x squared plus x plus 9 over the x plus 1. This is the x, this is the 0, this is the y. So this will be the graph for what they require you to state, to sketch. Now we need to solve the inequalities over here. So to solve the inequality, we just need to make them become equal. So you have a 2 modulus of x squared plus x plus 9, let it equal to the 13 modulus of x plus 1. So you get modulus of x squared plus x plus 9 divided by x plus 1 is equal to the 13 over 2. So which means that we are looking for this modulus graph, and then 13 over 2 is somewhere here. And we sketch a graph. This is the graph of y equal to 13 over 2. And you can see that over here, it will have 2 solutions. And we need to find these 2 solutions by breaking the modulus become no modulus. That means you will have one is a positive 13 over 2. Another one, it will be negative 13 over 2. So for the positive 13 over 2, you get this 13x plus 13. Then you get 2x squared minus 11x plus 5 equal to 0. Factorize it. Then you get this. X is a half and x is a 5. This one, if you try to solve it, negative 13x minus 13, you will get 2x squared plus a 15x plus the 31 equal to 0. So over here, actually, you also can check that your discriminant is less than 0. So just say that no real solutions. Therefore, you reject it. So the answer, 2 answers that we have over here, you can see from the diagram, is actually stated that this is a half and this is the 5. So in order for this to be greater, so that means it will be greater, then the answer will be here, this part and this part. So you can just say that this one, I make it become equal again. So from the graph, your x will be less than half, and then your x will be greater than 5. So this will be the answer for the question 7D. However, you can see the mark scheme. They mentioned that the answer is this. But according to the graph, the x actually cannot equal to -1. So should we mention that the x cannot equal to -1? Okay, so now the problem is, this is the original questions. When I change into this, you already modified you modify the equations already. Okay, this is the maybe we don't say original question. This is the original equations. Then when you change into this form, this is the modified equations. So when we solve the answer, actually we are solving using the modified equations. So for the modified equations, actually your x cannot equal to -1. However, if you go back to the original questions, if you go back to the original equations, your x equal to -1 is okay, no problem. So over here, actually, there's no need for you to mention that x equal to not equal to -1. So just leave it like this. We'll do x less than half and x greater than 5. That's all. Okay. So of course, in exam, actually, if you refer to the mark scheme, we are not required to show this in the answer. These are not required. So I shall just leave the answer for the y equal to the modulus of the function. Like this will do. No need to involve the y equal to the 13/2. So that will be the last question for this paper. I'll stop the video. I'll see you next time and bye-bye.